Why Einstein refused to believe his own equations actually created black holes. Get ready for an intense video. Fasten your seatbelt and grab a snack or some tea to enjoy while watching. Let's get started. In 1915, Albert Einstein wrote down the equations that describe gravity itself. Just months later, another scientist used those exact equations to predict something so strange, so extreme, that Einstein spent the rest of his life trying to prove it was impossible. That thing is called a black hole. And Einstein was wrong. It starts with general relativity. Einstein's theory said that mass and energy bend the fabric of space and time. A star doesn't just sit in space, it curves the space around it, and that curvature is what we feel as gravity. It was a radical idea, and it was mathematically brutal. Even Einstein struggled to solve his own equations for anything but the simplest cases. Then, from the trenches of World War I, a letter arrived. It was from Karl Schwarzschild, a German physicist serving on the Russian front. While calculating artillery trajectories by day, he'd solved Einstein's field equations exactly for a perfect sphere of mass. Einstein was stunned. He personally presented Schwarzschild's solution to the Prussian Academy of Sciences. But buried inside that solution was something bizarre, a radius where, mathematically, space and time seemed to break down completely. Today, we call it the Schwarzschild radius, the boundary of a black hole's event horizon. Cross it, and not even light can escape. But in 1916, nobody used that name, and nobody believed it was real. It looked like a mathematical glitch, a singularity, a place where the equations simply exploded into infinity. Surely, they thought, nature would never allow such a thing to actually exist. For over 2 decades, Einstein treated this singularity as a mathematical curiosity, a flaw to be explained away, not a real astrophysical object. He believed nature had some hidden mechanism that would always prevent matter from actually collapsing that far. To him, infinite density wasn't physics. It was a sign that the theory was being pushed somewhere it was never meant to go. In 1939, Einstein decided to settle the matter once and for all. He published a paper with a very direct goal: to mathematically prove that collapsed stars, what we'd now call black holes, could never actually form in nature. He imagined a cluster of particles orbiting each other under gravity and tried to show they'd always stabilize before reaching the dangerous radius. His conclusion? The Schwarzschild singularity was, in his words, not present in physical reality. Here's the twist. Einstein's math in that paper was actually correct. He showed that a cluster of particles orbiting like planets could never collapse into a black hole. But he'd only tested one specific idealized scenario. Real dying stars don't behave like tidy orbiting particles. They collapse under their own crushing weight all at once, with nothing to hold the pressure back. Einstein had proven a black hole wouldn't form his way. He hadn't proven it couldn't form at all. That same year, just a few months later, physicist Robert Oppenheimer and his student Hartland Snyder published a different paper. They modeled an actual collapsing star, one running out of nuclear fuel with nothing left to fight gravity. Their conclusion was the opposite of Einstein's. The star would keep collapsing forever, cutting itself off from the rest of the universe behind an event horizon. It was one of the first modern descriptions of what we now call a black hole. Well, why did Einstein dig in so hard? Partly it was philosophical. He believed a complete physical theory shouldn't produce infinities. Points where density and gravity become infinite felt like nature breaking, not nature working. Partly, it was intuition built over decades. General relativity was his creation, and he understood its elegant geometry better than almost anyone alive. But that same intimacy may have made it harder for him to accept a prediction that felt, to him, like an ugly exception rather than a real object. It would take decades for the astrophysics community to catch up. In the 1960s and 70s, physicists like John Wheeler, who coined the term black hole, and Roger Penrose, who proved mathematically that collapse to a singularity was unavoidable under very general conditions, finally cemented what Oppenheimer had glimpsed. Penrose would go on to win a Nobel Prize for that work in 2020. And in 2019, the Event Horizon Telescope produced the first ever image of a black hole's shadow, turning Einstein's rejected prediction into an actual photograph. There's a strange irony here. The man who taught the universe that gravity bends space and time couldn't quite accept where his own equations led. Einstein wasn't rejecting bad science. He was a brilliant physicist wrestling honestly with a prediction that seemed absurd, using the best reasoning available to him at the time. The end. Black holes turned out to be real. Not despite Einstein's equations, but exactly because of them. Sometimes even the person who writes the rules of the universe is the last one to believe where they lead.